Hey everyone, today we are tackling LeetCode number 347, top K frequent elements. This is a great problem to understand heap data structure and how it is used in different contexts. So without wasting much time, let's dive in. Okay, so let's look at the problem and try to understand it better. Here with the definition it's given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So let's look at the example here. 1, 1, 1, 2, 2, 3. So 1 has appeared 3 times, 2 has appeared twice, and 3 has appeared once. And when they are asking to return the top two most frequent elements, we are returning just 1 and 2. And in the same way, here only 1 is given as an element, and they are just asking the top one frequent element, and we are returning it as 1. Let's see some more examples here. In this one, here 1 is given 4 times, 2 is given 3 times, and 4 comes 2 times, and 3 comes only once. And here also they are asking to return the top two most frequent elements. And how do we go about solving this problem? In order to solve this problem, we will use two data structures, mainly a hash map and a min-heap. So in the hash map, we will arrange each of those numbers in the array given based on its frequency. So 1 appears, this should be 4. So the frequency of 1 is 4, frequency of 2 is 3, frequency of 3 is 1, and frequency of 4 is 2. So now it's correct. And we will insert all these elements in the num frequency map into a min heap based on its frequency. When I say based on its frequency, just keep that in mind. That's the most important thing. Here it is a min heap, but we can see that 3 is at the top. Usually in the min heap, the minimum value will be at the top. But why 3 is at the top here? Because we have told min heap, the criteria is based on the frequency. Here 3 has the minimum frequency. 3 has the frequency of 1. So that is at the top of the heap. And then 1 has the highest frequency. So that is at the bottom of the heap. But one inaccuracy here is we are interested only in the k top elements, so we will never maintain all these elements within the min heap. As soon as we exceed the number of exceed k in the min heap, we will try to pop one value out of it. So we will be removing the min heap, so we will be remaining it with only top k elements in the heap. So when this one, if we remove 3, if we have to remove 3, we will exchange swap it with the last value. First thing, as we saw in the heap data structure. So we will exchange it, and then I'll see the minimum value in both of these. So which is the minimum value here? Minimum value is 2, but minimum value based on the frequency is 4. 4 has the minimum frequency. So I'll be replacing 4 with this 1. So this one will become 4 and this one will become 1. And after that, there's nothing to compare with. So I'll leave as it is. And now we have 3 elements. Now we have 3 elements, but we do not need 3 elements also. We are only interested in 2 elements. Yeah, we end up with 1 and 2, which is the expected output. As explained in the steps, we can follow these simple steps in order to implement the solution. First one is count the occurrences of each element using a hash map. How do we do that? In order to do that, let's create a hash map here with the name num frequencies, and I'm iterating through each of the numbers in the nums array, and I'm putting that into the hash map. If the number already exists, then I'm just incrementing it by 1. If the number doesn't exist, then I'm assuming that the default value was 0, and then I'm incrementing it by 1. Once I have that uh, formatted data within the num frequency hash map, I'll have to use a min heap and store the most frequent elements. Again, I'm emphasizing most frequent elements in the min heap. So how do I do that? I'm creating a priority queue or the min heap here, and this is the part which defines it. So here a and b, if I'm considering the value a and b, let's say a is 1 and b is 2, how do I consider which is minimum? Not by the absolute value of this one, but I'm comparing it by the frequency that is there in the hash map. So the frequency of 1 is 3 and frequency of 2 is 2 here. So 2 is smaller than, so that makes 2 as smaller than 1 in this case because the frequency is lower. So that's how the min heap will assume 2 as smaller, and 3 is even smaller because it has further lower frequency. So once that is there, I'm iterating through. So I have defined that priority queue, and then I'm iterating through each elements in the hash map, and I'm adding it to the priority queue. Here in the, you can notice in this step, I'm maintaining the size of the priority queue or the min heap at most as k plus 1. As soon as it exceeds k, I'm polling an element or polling the minimum element out of the queue. So that will make sure that I have only top k elements within the min heap. And this will help maintain the runtime to log k. If not this one, if we didn't have this check, then the worst case runtime would have been log n. And if we had to maintain log n like that, I mean n log n, so if we needed n log n, then we could have simply sorted this nums array and just returned the top k elements. But this is the improvement here using the priority queue. Instead of n log n, we can make it n log k. Even though we are iterating through each of those elements, the min operation or the heapify operation would take log k only because of the size of the heap, which is k. Hope that is understood. You can understand the heapify operations and other heap related operations in another video that I made about heap data structure. And once this is done, the output format is expected in integer array. In order to do that, I'm just taking the elements out of the heap. So I'm initiating the top k elements with size k, and then I'm just adding the elements from min heap to that top k, and then I'm returning the top k. So that's about this problem. So this is a medium problem, and the main point to note here is I have arranged the numbers based on the frequency in a hash map, and then I have taken a min heap. In the min heap, I'm arranging the numbers based on the frequency, not on its absolute value, but based on its frequency. So that's the key. If you remember that, easy to solve this problem. There is another approach to solve this problem using QuickSelect. So that is a method. It is like quicksort, but we will not be sorting the part which doesn't matter for us. We just need to determine whether it is in the top k or after or smaller k minus 1 elements. So that's the only thing we are concerned. So we will be partitioning and we will be separating out the elements which is less than the kth element and which is greater than the kth elements. So in that approach would give an average runtime of O of n, but in the worst case that renders a runtime of O of n square. So that happens when the pivot element, like we are unlucky with the pivot element and we will be sorting only one element per step. That makes it O of n square in that approach. I'll be explaining the code and the details of that approach in another video. So if you have gained anything out of this video, please don't forget to like, share and subscribe, and also leave comments about the topics that I need to cover or the problems that you want me to solve. I'll make sure to prioritize that. So until next time, stay curious.